Good morning, students. Today we are going to discuss about the next topic of acids, bases and salts. It is the last part of the salts. The second is bleaching powder. The chapter is acids, bases and salts. Already we have discussed about the acids, we have discussed about the bases, the last part is salts. The salts, we have discussed about the kinds of salts. Now we will go for the 5 different salts which are there for our syllabus. This salt part is most important for our syllabus. Is having almost 4 marks for our syllabus. The 4 marks question will comes 1 plus 1 plus 1 plus 1. In that 4 marks, this salt, they will highlight more for the salt. Okay, go for that salt. In the salts, in the earlier class we have discussed about the kinds of salts. We are having 6 types of salts. The first one is the normal salt, second is acid salt, third is basic salt, fourth is double salt, fifth is mixed salt, and the last one is complex salt. Your acid salt, normal salt, where a strong acid reacts with a strong base to form a neutral salt or a normal salt. The process is also called as a neutralization reaction. When you go for the acid salts, normal salt, what happens? Complete ionization of hydrogen atom will be there. Sodium chloride and sodium sulfate is an example of the first salt, that is normal salt. If you go for the second salt, the second salt is acid salt. The first salt is normal salt. Its formula is, its example is sodium chloride and sodium sulfate. The second salt is acid salt, and this acid salt example is sodium bicarbonate. Sodium bicarbonate, where hydrogen is not totally, it is a partial replacement of hydrogen. Only partial will be there, not complete replacement of hydrogen will be there. Partial ionization will be there, and so it is called as acid salt. Third one is basic salt. Basic salt, lead hydroxide chloride. It is a basic salt. The fourth one, or the basic lead hydroxide, or basic lead chloride. Actually, it is a basic lead chloride. OH shows that it is a basic content lead chloride. The fourth salt is double salt. Yes, the double salt example was potash alum, as per your, remember, potash alum was the example. Potassium sulfate, alum, aluminium sulfate. It is a hydrated potassium sulfate and aluminium sulfate. Hydrated means the water content. Yes, the fifth one was mixed salt. Mixed salt example was calcium oxychloride. Actually, it is the next part of our syllabus, that is calcium oxychloride. it is having two basic radicals, or it will be having a single salt will be having two basic radical, or a single salt will be having two acidic radicals. It is having two acidic radicals. Now it is here we are having two basic radicals. A single salt will be having two acidic radicals, or two basic radicals. That is called as mixed salt. At last is complex salt. Yes, this complex salt, it is a formation from the simple ion and complex ion. The example is sodium argentocyanide. Sodium is a simple ion and argentocyanide is a complex ion. With the combining of both the simple and complex ion, we are getting a complex salt. These are the 6 salts. Usually, normal salt, the sodium chloride is there, it is already for our syllabus. Acid salt is there, it is already for our syllabus. Basic salt, we are going to learn the sodium carbonate. Double salt and complex salt are for the class 11 and 12. Mixed salt is calcium oxychloride. Yes, calcium oxychloride. This is the topic which I am going to learn now today. Already we have discussed about the earlier class we discussed about the sodium chloride. Sodium chloride solution will give us a different chemical. We are getting a 3 byproducts. That is, sodium chloride will react with the water in the presence of electric current. It is also called as electrical decomposition of sodium chloride. That is, sodium chloride solution, it becomes sodium hydroxide, it becomes chlorine, it becomes hydrogen. We are having three byproducts. That one is sodium hydroxide. It is called as alkali. I think so we are discussing this word. It is an alkali. Alkali is a base soluble in the water. Chlorine, it is called as chlor-alkali process. The formation of this chemical, it is called as chlor-alkali process. Now it is balanced. Chlor-alkali process. The whole process is called as. And we are having the use of sodium hydroxide. Actually, sodium hydroxide is used in the making of soaps and detergents. And if you take over the chlorine, it is used in the bleaching powder. And if you take over the hydrogen, it is used in the fuel for the rockets. Nowadays, instead of hydrogen, they are using hydrogen also for hydrogen. Instead of hydrogen, they are using hydrogen for the fuel for rocket. Chlorine for the bleaching powder, and sodium hydroxide, it is used for the soaps and making of soaps and detergents. Yes, apart from it, we are having a lot of uses. Already we discussed in the earlier class. Next, we will go for the second salt, that is bleaching powder. Bleaching powder. I think so all of you know about this bleaching powder. Maximum houses they are using this bleaching powder. Especially bleaching powder will be identified very easily with the help of that smell, a strong smell, and that smell is actually of chlorine present in it. It is also called as chloride of lime. Lime of chloride, because CaOCl2, chloride of lime, chloride of lime chloride, and calcium, it is also called as quicklime and chloride. Now it is a double salt. This is having oxygen and chlorine. These are acidic salts. It is a mixed salt. CaOCl2, its chemical name is calcium oxychloride. Yes, bleaching powder, it is present in the solid state, and it is having the yellowish white color, and it has been formed with the help of calcium hydroxide and chlorine. When the calcium hydroxide and chlorine reacts with each other, calcium hydroxide and chlorine, calcium hydroxide reacts with the chlorine to form calcium oxychloride and water. Yes, calcium oxychloride and water. Here is the bleaching powder. If we add the chlorine for the calcium hydroxide, becomes calcium oxychloride and water. Yes, and this bleaching powder, it is having a multiple uses. It is used as oxidizing agent in the so many industries. It is used to disinfectant in the water. The first one, uses. It is used as disinfectant in the water, to clean the water. To clean the water is used. It will kill all the germs present in the water. To clean the water, they are using this bleaching powder. The second one, it is used for the making of or the bleaching of cotton industry, for the cotton in the textile industry. And if you go for the second sub part of this point is wood pulp. I think so. Seen about that wood pulp. Wood pulp in the paper industry. Yes, it is used to bleach the cotton in the textile industry and for the bleach the wood pulp in the paper industries. Yes. The third point, yes, it is also used as an oxidizing agent in these both the factories, textile industry as well as paper industry. Yes, we are having about the bleaching powder. Bleaching powder is a simple chemical already we are using in the home. Bleaching powder will be identified by through its smell very easily. That smell is of chlorine. Yes, it is a mixed salt. It is yellowish white color, and it is solid in nature. Its formula is calcium. Formula is CaOCl2, and its chemical formula is calcium oxychloride. When you go for its formula, how it is prepared? The bleaching powder is prepared with the help of calcium hydroxide and chlorine. When calcium hydroxide reacts with the chlorine to form calcium oxychloride, along with the water. It is used as disinfectant in the to clean the water. Second is used to make the bleach of cotton in the textile industry and bleach formable in the paper industry. Also, it is used as a oxidizing agent. Oxidizing agent in both the textile industry as well as paper industry. This is about the bleaching powder. Next, we are going to discuss about the next part, that is the third salt, sodium bicarbonate. Yes, sodium bicarbonate or baking soda. Its formula is NaHCO3. The formula, I think so all of you know about the baking soda. Baking soda we are using in our daily life, especially in the cooking purpose. We are using this baking soda. Okay, NaHCO3, sodium bicarbonate. Sodium bicarbonate, or it is also called as sodium hydrogen carbonate. Sodium bicarbonate or sodium hydrogen carbonate. Once it is in the solid state, and actually it is an acidic salt because it is having one of the hydrogen in its chemical. As partial replacement of this chemical, actually hydrogen is remained, not complete dissociation, only partial dissociation of hydrogen atom is there, and so sodium hydrogen carbonate is there, so it is called as acidic salt. Acid salt it is. This is a acid salt. Okay, how this salt has been prepared? We go for this part. When sodium chloride, see once again we are going to sodium chloride, because we are having a lot of uses for the sodium chloride, and sodium chloride is also used to make multiple products. Sodium chloride, when it reacts with the carbon dioxide, water as well as ammonia. Sodium chloride, carbon dioxide, water and ammonia. When the four of the chemicals, when they react with each other, we are going to get two chemicals, that is, one is ammonium chloride. One is ammonium chloride, the second is sodium bicarbonate. Here we have got it, and the process is called as Solvay process. Sodium bicarbonate is available when the ammonia and carbon dioxide is reacting with the sodium chloride along with the water. The chemical is ready, it is ammonium chloride and sodium bicarbonate. Okay, this is the salt is ready, and this salt, even if you go for it, if you go for the thermal decomposition of sodium bicarbonate, you are going to get some more chemicals. Thermal decomposition of sodium bicarbonate. Thermal decomposition of sodium bicarbonate, you are going to get sodium carbonate plus carbon dioxide plus water. Yes, we are going to get these all chemicals when we are heating this chemical. When we heat this chemical, we are getting sodium carbonate. Yes, and when we heat this sodium carbonate, we will get sodium oxide and carbon dioxide, because these all reactions are very very important, all are correlated with each other. We have got the sodium bicarbonate. When sodium chloride is reacting with the ammonia, water and carbon dioxide, we have got the ammonium chloride and sodium bicarbonate. This sodium bicarbonate, if you go for thermal decomposition of this sodium bicarbonate, we are getting sodium carbonate, carbon dioxide as well as water. And this sodium carbonate, when you go for the decomposition reaction, they are going to get sodium oxide and carbon dioxide. Yes, because sodium carbonate, if you are getting it, it is linking with the next part, that is washing soda. Next, automatically it links with the washing soda, and this is helpful for this. The next part, that is acid, soda acid fire extinguisher. These all are interlinked. We will discuss one by one, because we go for the uses of this baking soda. Now we are going to learn the uses of baking soda. The first uses. Yes, it is used as an antacid. Already we have discussed about this part, this uses in the earlier session of bases also. There was a chemical called as magnesium hydroxide. It is a base, and that magnesium hydroxide used as antacid. Now, the baking soda also used as antacid. It is also used as antacid. It releases from the acidity. Usually people will go for that eno. It will be having this chemical, sodium bicarbonate. Yes, used as an antacid. Yes, it is also used in the cooking purpose. I think so all of you know about that. It is used in the cooking purpose. The third one is, it is used as soda acid fire extinguisher. It is used in the making of fire extinguisher, because sodium oxide and carbon dioxide is liberated. Automatically it is used as fire extinguisher. Yes, I told you, uses are there, applications are there only. Now, it is also used to making of baking powder. This baking soda is also used to make the baking powder. When this baking soda is reacted with the edible oil, we are going to get a chemical called as sodium tartarate, salt. Yes, the baking soda, baking powder is ready. When the baking powder is ready, that will mix the food or the food materials very soft and spongy. So only they are using this chemical. Baking soda is also used to make the baking powder. Baking powder is prepared with the help of reaction of baking soda as well as edible oil. Okay, this is all about the sodium hydrogen carbonate. Sodium hydrogen carbonate. Next is the last, that is after baking soda we are having the next chemical is washing soda. The fourth chemical is washing soda. I think so. Automatically the word comes. It is used for cleaning the clothes, especially in the rural areas. Yes, washing soda. Its formula is Na2CO3 dot 10H2O. Na2CO3, it is sodium carbonate. It is a basic salt. Now we have got, this is a basic salt. Na2CO3, sodium carbonate. Even the water content is there along with this sodium carbonate. It is also called as sodium carbonate decahydrate, because 10 molecules of water is there, so it is called as sodium carbonate decahydrate. Okay, this is all about the washing soda. Washing soda, actually all of you have seen it. Once again, it is used in the homes only. How it is prepared? That is the first point. Yes, already we have discussed about this point in the earlier salt only, that is soda, that is baking soda actually. Baking soda, if you heat the baking soda, thermal decomposition of baking soda will get washing soda. Not washing soda, actually we are going to get sodium carbonate. Sodium carbonate plus water plus carbon dioxide. Yes, we have got sodium carbonate. Sodium carbonate is ready. This sodium carbonate reacts with the 10 molecules of water to form sodium carbonate decahydrate. It is a washing soda. Yes, sodium carbonate actually it is formed with the help of thermal decomposition of sodium bicarbonate only. From baking soda we are going to get washing soda. If you heat the baking soda, you are going to get washing soda. It is not washing soda. Sodium carbonate, a part of washing soda, water and carbon dioxide. And this sodium carbonate, when it reacts with the water, it forms sodium carbonate decahydrate. Yes, this is the formula. Now we are going to discuss the next part, that is the uses of washing soda. The first point of this washing soda, I told it, it is used for the cleaning of clothes, especially in the rural area. Yes, cleaning of clothes. Yes, cleaning of cloth. The second point, actually especially in the rural areas they are using this washing soda. The second point, it is used to remove the permanent hardness of water. It uses to remove the permanent hardness of water. Yes, what is this permanent hardness? We know about the hard water, but here they have mentioned the word permanent hardness. Means when the water is having permanent and temporary hardness. Which chemical will mix or which salt will mix is water as permanent hardness and which will mix temporary hardness? Usually sodium chloride is there, magnesium chloride is there, calcium chloride is there. but the sodium chloride, if you add for a water, it is not called as a hard water. But if the water contains magnesium chloride or magnesium sulfate, I repeat, if the water contains magnesium chloride or magnesium sulfate, or calcium chloride or calcium sulfate, out of four salts, if any one salt is present in the water, it is called as the water is permanently hard. If the salt of magnesium chloride is there or magnesium sulfate is there, calcium chloride is there or calcium sulfate is there, so only if it is present in the water, that water is called as permanent hard water. Permanent hard water. Then what makes it as temporary hard water? Temporary hard water. This will make permanent hard water. These salts present in the water makes the water permanently hard, which makes temporarily hard. That is magnesium carbonate or calcium carbonate. See here, these all salts are from the magnesium or calcium. These are making temporary hardness. Temporary hardness can be removed with the help of boiling only. By boiling we can remove the temporary hardness of water. Permanent hardness of water can be removed with the help of washing soda, or one more process is there. The process is called as permotite. It is the magnesium chloride, magnesium sulfate, calcium chloride, calcium sulfate will mix the water as permanent hard, and this process and this hard water can be make it soft with the help of washing soda or a process called as permotite process. And if a water consists of magnesium carbonate or calcium carbonate, means carbonates of magnesium or calcium, it makes the water as temporary hardness and it can be removed with the help of boiling. Okay? Usually this question has arrived for multiple times. What is the process to remove the permanent hardness of water? It is washing soda is also there. It is also there with the permotite process. Permotite process. Okay? We will go for the next part of this topic. Yes, the third point, it is also used in the making of glass. In the glass industry also, making of glass, they are using this salt, that is sodium carbonate, for the making of glass. It is a product. It is also a material, raw material, which is used to make the glass. Yes, washing soda, that is sodium carbonate. Actually, sodium carbonate is used for the making of. It is also a raw material for the making of glass. Okay, these are the points related with the washing soda. We will go for the fifth salt, that is plaster of Paris. Yes, plaster of Paris is a salt, hydrated salt of the calcium actually. Calcium salt it is. Calcium sulfate hemihydrate. Plaster of Paris, its formula is CaSO4.12H2O, and it is called as calcium sulfate hemihydrate. Hemi because it is half molecule of water is there, so it is hemihydrate, and it is prepared with the help of a chemical called as gypsum. It is prepared with the help of a chemical called as gypsum. Gypsum, if you heat the gypsum at 100 degrees Celsius or 373 Kelvin, you are going to get this chemical. Just you will go for it. With the help of gypsum. Actually, keep in mind, this gypsum is used in the making of cement also. It is a raw material for the making of cement. A very small quantity of gypsum will be used. Very small quantity, hardly of 2 or 3% of gypsum will be used, and this gypsum is used for the setting rate of cement. Okay, let's go for the plaster of Paris. Gypsum formula is CaSO4.2H2O, and if you heat this gypsum at a temperature of 100 degrees Celsius or 373 Kelvin, at that time, if you heat at 100 degrees Celsius, you are going to get plaster of Paris, CaSO4.12H2O, and the remaining content of water is separated. Yes, the gypsum is used. Yes, here if you heat the gypsum at a temperature of 100 degrees Celsius, we are going to get plaster of Paris, POP. It is famous as the word POP. Okay, and once again you are going to regain the same chemical. How it is? If you take calcium sulfate hemihydrate, and if you add the water, if you add the same quantity of water, you are going to get once again the same chemical, gypsum. Both processes are available. Both are right. It happens in this way also. If you heat the gypsum, you are going to get calcium sulfate hemihydrate, that is plaster of Paris. And if you add water for the plaster of Paris, once again you are going to get the gypsum. Okay. The last part of this topic is what are the uses of plaster of Paris. I think so. POP, it is used in the ceilings of the home. I think all of you have seen about it. Let's see the uses of plaster of Paris. Ceilings of house, making of toys, making of statues or idols. Then using these all chemicals. Plaster of Paris is used for the making of ceilings of the house, toys, making of toys, for the making of idols, especially Ganesh Chaturthi. You have seen that the idol of that Ganesha, Lord Ganesha, it will be of with the help of plaster of Paris. And even it is used for the setting of fractured bone, especially used by the doctors. I think all of you know about these all things. Fracture, there will be fracture for our hands, and they are using this plaster of Paris for the setting of that fractured bone. This is all about the topics, 5 different salts which are used in our daily life. This is the most important one. I repeat about all the 5 salts once again back. The first salt is sodium chloride. It is having 3 byproducts. Sodium chloride, I'll write all the reactions that will be useful for you. Sodium chloride, when it is reacting with the when it is reacting with the water, it forms sodium hydroxide, chlorine and hydrogen. The chemical, we are getting three products of the sodium chloride, that is sodium hydroxide, chlorine and hydrogen. Electrical decomposition, which is also called as electrical decomposition of sodium chloride, lead to the chlor-alkali process, where we are getting chlorine and alkali as sodium hydroxide. Okay. Second is it is about the sodium chloride. Second chemical is bleaching powder. Bleaching powder, it's how it is prepared with the help of calcium hydroxide and chlorine. Calcium hydroxide is reacting with the chlorine to form calcium oxychloride and water. It is the second reaction, calcium oxychloride. The third chemical is we are having the baking soda. How the baking soda is formed? Baking soda is formed with the help of, once again, the calcium sodium chloride. Sodium chloride is reacting with the ammonia carbon dioxide as well as water. Ammonia carbon dioxide as well as water, we are going to get ammonium chloride. Ammonium chloride and sodium hydrogen carbonate or baking soda. Yes, third one. The fourth is washing soda. How we are going to get washing soda? Washing soda, we are going to get with two different reactions. If you go for the first is thermal decomposition of sodium bicarbonate. In the HCO3, if you heat it, you are going to get sodium carbonate, water and carbon dioxide. Now this sodium carbonate reacts with the water, it forms sodium carbonate decahydrate. This sodium carbonate decahydrate, it is the next chemical. The last one, the fifth one is plaster of Paris. Plaster of Paris is formed with the help of heating of gypsum. If you heat the gypsum, the formula of gypsum is CaSO4.2H2O. If you heat gypsum at the 100 degrees Celsius or 373 Kelvin, you are going to get calcium sulfate hemihydrate plus 1.5 molecule of water. Calcium sulfate with 2H2O, it is dihydrate, it is gypsum, and it is plaster of Paris. Okay, if you heat this gypsum at the temperature of 100 degrees Celsius, you are going to get that plaster of Paris along with the water. These are the 5 different salts, how they have been prepared, okay, or how they have been formed. Okay, today by evening you are going to get the notes. It is question and answers of this, the whole chapter actually, 6 basic and salts, question and answer, that is in text question and answer, as well as NCERT solutions. Okay, this is the end of second chapter, and tomorrow we are going to do the first experiment of our syllabus, that is study of pH value of different chemicals. Around 6 chemicals are there, we are going to discuss tomorrow. Okay, thank you to one and all.